Hi and welcome to our video on observing the moon and some ideas on learning about the moon as well. So the moon is something that a lot of astronomers hate or dismiss because it's so bright it can drown out everything else in the sky. But it's actually a great object for learning about astronomy and for getting into astronomy and learning how to use beginner or basic equipment such as beginner telescopes. So I'm going to go through some activities you can do to learn more about the moon, either for yourself or if you've got friends or family that you would like to do activities with, you can do these as a group together. And then we'll go on to how to observe the moon. So our first thing we're going to look at is research-based activities. One of the easy ones to start with is looking at different myths about the moon from around the world. Every culture has some form of creation myth, and usually there is a myth about the Earth, the Sun, and the Moon. So there is such a rich repertoire of stories to pick from different countries around the world. Different cultures from the same places at different times also have different takes on it. So it can be a really interesting way of getting into studying the moon by studying the different stories about it and what different people thought about it. We also have the very human stories of the Apollo to Artemis missions. So the space race, the moon landings, there are some incredible humans that were involved. The science, which was so amazing for its time, but yet so simple as well. If you think we went to the moon on technology that is less advanced than maybe your car key, it's absolutely wild to consider. So the stories behind the astronauts, how they got there, all the different phases. You've also got movies like First Man and Apollo 13. You could have a moon viewing night. But now we have the Orion and Artemis missions to go back to the moon. India have just done their soft landing on the South Pole. And we also have the Near Rectilinear Halo Orbit Gateway, which is the plan for a space station to orbit both the Earth and the moon. There is a lot going on in terms of space history, but also things moving forwards in the space technology world. Another fun one to do is to look at the names behind the craters. All the craters on the moon are named after notable scientists that have had some kind of contribution to science that is deemed important. So there are 9,137 craters that we know of, and only 32 are named after women scientists, which is a shame because women have been doing science throughout time and assisting people that got credit for a lot of work. But it's really interesting to go through and look at the crater names and research the person behind those crater names and find out more about them. Tycho crater, one of the biggest and easiest to see craters of the moon, even with the naked eye. So it's the big one if you're in the northern hemisphere, and I'm sort of London latitude. So to me, it looks like it's at the bottom of the moon in the Sea of White. But if you're somewhere else in the world, the moon might be oriented differently. So look up Tycho, Tycho, and you'll find that crater on a lunar map somewhere. That's named after a scientist called Tycho Brahe, and his life story is wild. He was sold to his uncle at the age of 2 because his parents couldn't afford him. He had a great life in terms of he was set up as a nobleman, and at university he discovered he was particularly good at maths and science. And he got into an argument with someone about who was the best mathematician. Of course, the only way you can solve that argument is apparently a duel in which he lost his nose. So then he had a prosthetic nose that he thought was silver, and in 2010, when they exhumed his body, they discovered it was actually probably brass and some other kind of alloy. He ended up having an observatory which was in a castle on an island, and he ended up with his own personal army. He had a pet canoe. There are so many wild, wild stories about Tycho Brahe that you could just read about and believe that it's some kind of crazy made up story, and it's really not. That is someone's life, and yet he rewrote a lot of the astronomical calculations that were needed in order for further people such as Kepler to come along and be able to come up with their theories of planetary motion. So Tycho contributed hugely towards astronomy as modern science, and as such, he gets a big crater named after him. But he was a character, so sometimes reading into these stories can really give you a feel for the history of astronomy and how we got to where we got to. We also have a number of religions and cultures that involve the lunar calendar. So most people have heard of Chinese New Year, usually in February, and that is because they are basing their year around the lunar calendar. We have Ramadan, which is also based around the lunar calendar. You may have heard of various full moon parties in places like Thailand. There are also various different calculation dates in other religions. So for Easter, my understanding is that it is the Sunday after the first full moon. It could be new moon, I'm not entirely sure on this one, after the spring equinox. So lots of different cultures use the lunar calendar, and it can be really interesting to find out which ones do. So those are all the sort of research, history, human stories behind the moon. You can also do science-based activities on the moon. So with this, one of the best things to do is just let your mind wander and start asking questions. For example, how does the moon create tides on Earth? And for those of you who really want to nerd out on it, in the Pacific, sometimes there is one tide a day, not two high tides a day. Finding out more about the moon's role in lunar and solar eclipses, and why does it turn red or orange? What is a supermoon? It does not involve a cape. It involves the moon's slightly elliptical orbit. Finding out more about moon phases and what they have to do with the times of moonrise, moonset, and the tides. There are a number of theories on how the moon was formed, and actually they're all very interesting, even though the Theia hypothesis is the best fit. And also, you may have heard of moonquakes. There are quakes on the moon, but the moon doesn't have tectonic plates like the Earth does. So what causes them? That can be a really interesting rabbit hole to go down. So to find the answers to these, you can look up on various search engines. YouTube is a great place. There's a ton of really great science channels now that will have the answers to these with really awesome animations and graphics to help you through it. So you can find out quite a lot about the moon just by doing some fun research. You can also become a citizen scientist. So maybe you wanted to do science and got distracted by something else. Maybe you did a science degree and ended up getting an office job or something else that isn't in science. Or maybe you've got kids who want to do some science-based research at home. There are now lots of opportunities for citizen scientists. Citizen scientists are given data for classifications in some way, shape, or form, and you are trained in how to classify data. And this can really help with research speed and time, because some of the projects you would need maybe a graduate student to spend several years to get to the same place that several hundred citizen scientists can get to in a couple of weeks if you're all screening the same material. Now, obviously, they go through and check, spot check work, etc. But usually, if you've got so many people working on a project together, you're going to get a number of overlapping sort of positive results that will help sort of drown out people who have made mistakes. So citizen science is really interesting. You can do some really fascinating projects. At the moment, NASA has a moon disk project where you're spotting before and after pictures from different missions. And there is also a platform called Zooniverse, where it started with galaxy classifications, and that's where I started with it. And now they have a ton of projects, not just in astronomy, but in just about every area of science. So you can find something there if you're interested in becoming a citizen scientist. We also have art and craft activities, which can be great fun. So you can try making a 3D moon. So you can do it the paper mache method, like you probably did at school. So you get a balloon, you do a paper mache sphere around the balloon, pop the balloon, and then you can start painting the surface to match pictures you can find online. If you're into tech, you can 3D print your own moon. You can even buy 3D printed moons now. You can have a go at drawing the lunar disk, the lunar craters. You can do moon inspired art, so thinking again about the cultures and myths. You might have some particular feelings about the moon and therefore have something a bit more abstract. That's just as valid when it comes to art. There are also some brilliant photos from the Lunar Reconnaissance Orbiter mission that you can use for reference. So at Guildford Astronomical Society, we had a lunar sketching workshop. I have no artistic talent whatsoever, but these are some of my earlier attempts at the moon. It's not spot on, but it was great fun. It's super relaxing, and I really enjoy doing them. So finally, we're on to observing the moon. So there are a few things that we need to take into account. First of all, safety first. This is really important. Going out in the dark by yourself is not always the safest thing to do. If you've got your own secure back garden, great. If not, find a group of people like your local astronomical society and do observing as a group together. Or maybe you've got friends or family who can go to a place that's relatively safe. So, safety first. There's also safety from the point of view if you're going out at night, it's dark, the ground may be uneven, there may be tree branches and things that you trip over. So make sure you've got a good red light torch just to make sure that you are safe in terms of not tripping or falling in a particular location. Next is light pollution. Now, you don't need to worry about that too much with the moon. You're still going to see the moon even if you've got lots of streetlights around you. However, if you do have a good telescope or binoculars you want to break out, you might want to find somewhere less light polluted. So getting away from light pollution as much as possible. It could be if you're in a back garden, turning off your security floodlight around the back of the house, and then you will get a few more details come out. Or it could be that if you're in the city going to an open park location at night, or a star party might be a better option for you. If you have binoculars or a telescope, you can break those out. Work out how to use them during the day first, so you're not trying to assemble things at night in the dark whilst the moon is possibly drifting out of view or might be lost behind clouds. And then actual observing, you can get started with checking out the different phases of the moon. I highly recommend looking at the moon several nights in a row and watching the terminator line move across the surface. So the terminator line is the line between night and day. And when you've got that terminator, the shadows along the craters get longer and more exaggerated, so you can really get a feel for the lunar surface, even with the naked eye, when you look along the terminator line. If you've got binoculars or a telescope, you'll see even more detail. And watching the phase change as the terminator creeps across the surface can give you a really good feel for that the full moon disk doesn't. And that's because the full moon is so bright it just drowns out all the detail. You can also take a look at the moon between day and night, and you will see there are different things about the appearance, and you can see different details at different times. A bit like when you look at something in colour and when you look at something in black and white, different details come through. The next thing to take a look at is, can you spot the maria? So the maria are the seas and the ocean on the moon. They're not liquid seas and ocean. They are from very deep crater impacts that revulcanized the moon and then set as lava plains, and they are basalt. So they look darker, and then the lunar highlands are the lighter areas of the moon around them. So can you see the dark areas versus the lighter areas? And then finally, there are some craters that you can see with the naked eye. But if you've got binoculars or a telescope, you're going to start seeing a bit more. So can you see some craters on the moon? And you can start by having a look around the terminator line, but even with the full moon disk, you can see some, and we'll talk through those in a second. And whatever your observations are, whether it's scientific, like what the weather was, where you were, what the view of the moon was, bear in mind you'll need a south-facing view. You can make a note of what you saw, whether you saw craters, whereabouts you saw craters, maybe even just do a little quick drawing of what you noticed. And then you can label it and highlight anything that you spotted that was different or unique that you want to look up the next day. Especially if you can get hold of a lunar map. They're quite cheap and easy to get hold of on Amazon or any kind of bookshop. Maybe you had really big thoughts and feelings, and you can write about those and turn them into something artistic later on. So I'm going to look at a few images of the moon now and tell you what you can look for, both with the naked eye and on the telescopes. So here you can clearly see the dark patches, the maria. You can learn the names of these. So the large dark patch on the left-hand side is the ocean of storms. And then sort of coming out the sort of top section, there's a roundish area, that's the sea of rain. We next have at the bottom the seas of moisture and the seas of clouds. Across the top we have the sea of cold. And then if you were to roughly cut the moon in half, that next maria sort of going towards 1 o'clock, you've got the sea of serenity. To the right of that, you've got the Sea of Tranquility. The next one along is the Sea of Fecundity. And then down from there, you've got the Sea of Nectar. And right up, sort of around 2 o'clock-ish, you've got the Sea of Crises. So you can learn all the different maria names. There are actually other maria there as well, with names, but those are the big ones. Then at the bottom of this one, you've got Tycho crater. So that's the big sort of white splotch at the bottom towards 6 o'clock. If we go up to the middle of the moon and then to the left a bit, we've got Copernicus crater, and then we've also got Kepler crater further along to the left. And then if you go up and then to the left a little, you've got Aristarchus crater. They are great craters to research, but you can see other craters there as well. Now, with the naked eye, you're probably going to just spot the maria, the uplands, and maybe some of those lighter craters. You can see the detail on this photo that there are other craters as well. You can also see ejector rays coming out from the craters. So if you have a telescope or binoculars, you might be able to see those features in more detail. Next, we're going to take a look at moon phases. So hopefully this video animation is just starting. You can see the terminator line moving across the surface, and this is delineating lunar night and day. And you can see those shadows increasing as the terminator moves. So you get a real feel along that terminating area of the craters as it passes. And then you can see this full moon disk. Those are pretty washed out because there is so much light on the moon. You just can't see those detailed. But when that terminator passes again, you will see again, you can see those craters showing up with those elongated shadows and get a real feel for the surface. And again, you can still get a feel for this with the naked eye, but with telescope binoculars, you can see some spectacular changes. So this is why I love observing the moon several nights in a row. Now, if you do have some pretty spectacular optics, such as a telescope, you might be able to get some crater features. So the features you're going to see are not going to be as amazing as this picture, but you will see a crater rim, and usually there are slumped terraces going down from the crater rim, and there is a central peak in most craters as well. And this is because when smaller impacts impact the moon, you get, like when you drop water into more water, the liquid moves out into a circle, and here the impact causes the rock to melt a little bit, so it goes out into the circle to create that rim and then solidifies in place, and then some of that rock will then rush back and move into the middle, which will then solidify, and you get the central peak. On this picture, which is beautifully detailed, you can also see little craterlets. You can see these little lines, and these are called rills. They're lava tubes from back when the moon was actively volcanic. So there's a lot of really interesting geological features on the moon, and if you want to really get into those, if you look at the Lunar Reconnaissance Orbiter mission photos, there's a ton of them there, so you can really get into it. Okay, so those are my tips for getting started with observing the moon. If you do want to know a bit more and you are anywhere in or around Guildford, you can look at joining Guildford Astronomical Society. We're membership based, but it's not for profit, so you just sign up as a member. We have monthly lectures by experts in different astronomical subjects at the university. We have a visual astronomy group, so we meet up once a month to do visual observing together in a dark place, and again, safety. We also have some great mentors that can help you get the most out of your equipment and help you identify things in the sky better as well. We have an astrophotography group. We meet up online once a month. We help each other out with our imaging. We have an exoplanet hunting group that's just starting up. So that's helping people work out how to detect exoplanets with the equipment they have at home. We also do have private larger telescopes for members to use in small groups. And we do a number of outreach activities for various groups and for the public to share our passion and interest in astronomy. So if you want to know more, you want to become a member, you can go to www.guildfordas.org, and we'd love to have you. Thank you for your time, and hopefully now you know how to get started with observing the moon.